And that's true. I mean, now you would text people, but it's just a good idea all around to stick around with your teacher in an emergency situation. Please and thank you. I would really appreciate it. Okay, put your phones down and take some notes. We're going to talk about writing polynomials. Okay, here we go. Nope, we don't go. Here we go. Writing polynomial functions. Use the zeros to write the factors of the polynomial. Okay. We're basically working backwards. The problems that you got yesterday that look like polynomials in standard form, that's the answer we want to have today. And then the answers that you got yesterday where you say the zeros are 4, 3, 1, those are the problems that we're going to get today. So we're working backwards. Remember that if like 2 is a solution to the polynomial, what does the factor look like? Is it x plus 2 or x minus 2? If 2 is an answer. If 2 is an answer to your polynomial, a solution to your polynomial, did the factor look like x plus 2 or x minus 2? It looked like x minus 2. So when you put them back, they always look like the opposites, so that when you solve, you can add or subtract from both sides. Okay, so use the zeros to write the polynomials. Multiply and combine like terms. Those of you who did your homework, you practiced this on page 170. Okay, 21 and 23. Were 2 multiplication problems. You distribute all the terms and then you combine them. Okay, so we already know how to do step 2. And I want everybody to write their final answer in standard form. That way, Jacob's answer looks like Jackson's answer, looks like Skylar's answer, and everybody's answer looks the same in standard form. And the only other thing I'll say is be very careful with your signs and your multiplication. A positive or a negative will make a big difference when you're combining like terms, whether you're adding or subtracting terms. And be careful with like multiplication. A lot of times when you're multiplying polynomials through distribution, I get a lot of 2 times 3 is 5. 2 times 3 is actually 6. And I get a lot of 3 times 3 is 6. 3 times 3 is actually 9. Okay. So be careful with that and make sure you're actually multiplying and not adding. That's like a simple error, but it gets really frustrating for you guys when you never have the right answers. And it could be something so small. Okay, so let's write the polynomial that has the zeros 3, negative 1, and 5. This is a sample problem from what you'll do on your homework assignment tonight. Write the polynomial that has zeros 3, negative 1, and 5. Well, first, write them as factors. So if 3 is a solution, what did the factor look like? X plus 3 or x minus 3? Minus 3. So that when you set it equal to 0, you add 3 to both sides and x equals 3. If negative 1 is a 0, then there was a factor of x plus 1. And if 5 is a 0, there was a factor of x minus 5. So this is a polynomial in its factored form. And we want to put it into its standard form, so we have to go through the process of multiplication. Okay. Now, I always like to multiply the last 2 factors first, and that's just my own personal preference. I will take x plus 1 and multiply by x minus 5, because I like to get a trinomial here, and then multiply a binomial by a trinomial. Do you have to do it that way? No, you can do the first 2, and then you'll multiply a trinomial by a binomial. So it's totally up to you what order you want to do it in. I'm going to do the last 2 first. And I'm going to take a little bit of a shortcut here on my multiplication. Okay. So I know for my first terms, x times x is x squared. And then I often do this in my head. I'll write down what I'm thinking, but I'm not going to write out all 4 terms in this group of parentheses. I'm going to say that my outside terms in distribution, x times negative 5, I'd be thinking in my head will give me negative 5x. And my inside term here will give me a plus 1x. And I'd just sort of be thinking about outside and inside, negative 5x and 1x, and then I'd combine them. So negative 5x plus 1x is negative 4x. And I'm going to do a little bit of my work combining in my head because I've FOILed so many times, I think I can do that. Now, if you're uncomfortable with that, you could write out all 4 terms and then combine like terms. Okay, so that's totally up to you. Now, I still have to do my last term. Positive 1 times negative 5 is negative 5. Okay, but either way, if we were multiplying x plus 1, x minus 5, showing all our work, or doing mental math, we'd come up with the same trinomial. Now, what's that? Because I have to take positive 1 times negative 5. So I got to do x times x times negative 5, 1 times x, and 1 times negative 5.
So did you just FOIL it?
Yes.
Or you did it like your way?
I was FOILing it in my head because I didn't want to write down all my work. You can write down all the work, right? Some of us feel comfortable where we're like, we could FOIL without having to write everything down. And some of us still want to write stuff down. Either way is cool, as long as you get the same answer. Okay. Now that's not my final answer. I have to multiply by x minus 3. On this one, I will show all my work because that's too many terms to keep track of. Because when I distribute, I'm going to get 3 for the first distribution and 3 for the second distribution. And I won't be able to keep track of all my different terms. Okay. So I'm going to start by distributing my x to all 3 terms. And I'll get x cubed minus 4x squared minus 5x. And then I go back and I take that negative 3 and I multiply it by all 3 terms. And you know, we talked about this in section 4.2. I like to stack up my like terms when I have bigger than FOIL, like a trinomial there. So that makes it really easy for me to combine my like terms because I kind of put them together. Do you remember doing that? And then combine my like terms and there's my polynomial. X cubed minus 7x squared plus 7x plus 15. Cool. So that looks like the problems from yesterday, right? That could have been any one of those problems I gave you yesterday and said find all the solutions. And then you would make a list of possible solutions, p's over q's, plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. Then you do synthetic guess and check. And when you did synthetic guess and check, you'd get the answers 3, negative 1, and 5. So we're going reverse. Does anybody have any questions about that? Okay, could you please try this one for me? Write the polynomial with the zeros negative 2, 3, and negative 3. Just 1 second, let me make sure everybody has the right factors up. As I walk around, I think everybody has the right factors, but you might double check. Should be x plus 2, x minus 3, and x plus 3, and then you need to work on multiplying. It'd be nice if you could multiply all 3 at once, but you can only multiply 2 at a time. And you can pick either 2 that you want. Yeah. Well, there were. There was a negative 5x and there was a plus 1. There was a 3x and a negative 3x. Okay, I noticed a lot of people are multiplying very similar to the way that I do, which is, I think is great. Multiply at the back. And something very interesting happens here, which is going to be useful to us in our next examples. because you have x minus 3 and x plus 3, when you multiply these out with FOIL, your outside and your inside terms are going to cancel out. So I think I created some confusion by doing some mental math. So I'm actually going to write out all my steps to FOIL. Okay, if I were going to FOIL this out, I would get x squared plus 3x minus 3x minus 9. And then plus 3x and minus 3x will cancel out. So that will be just the binomial x squared minus 9. And that's like a difference of perfect squares, which factors out to be x plus 3x minus 3. So that works out. Remember that you still have to multiply by x plus 2. Okay, so don't forget about that other factor. And then you just redistribute. Now, interestingly, this one has an x and the second one has an x squared. So you won't have any like terms that combine. When I distribute, I'll get x times x squared, which is x cubed, and then I'm going to do a 2 times x squared, so I keep it in standard form. That'll be plus 2x squared, and then I take x times negative 9, so I get minus 9x, and then I still have to do 2 times negative 9, so I get negative 18. But do that work and double check that you can get those 4 terms, x cubed plus 2x squared minus 9x minus 18. Any questions? Okay, now, this is where things are changing a little bit, but using that pattern of x minus 3x plus 3, that's going to be very helpful to us. Okay, how the outside and the inside term cancels. So we're going to talk really quickly about something called the irrational conjugates theorem. Irrational just means we're talking about irrational numbers. What kind of numbers are irrational? Square roots of non-perfect squares. Square root of 2, square root of 3, square root of 4. Nope, square root of 4 is rational. Square root of 5, square root of 6, square root of 7, square root of 8. Okay, those are irrational numbers. If a plus b, or sorry, a plus square root of b is a 0, then its conjugate, a minus the square root of b is 0. On the problems that we do, a will actually be equal to 0. So we're going to focus on the square root of b. If a positive square root of b is a 0, then a negative square root of b is also a 0. When you think about this, this makes a lot of sense. Because when we get square root answers, it either comes from solving by taking square roots, and what do you always add when you solve by taking a square root? X squared equals 36. Take the square root of both sides and add plus or minus. So if the positive one is a solution, then the negative one was also a solution, right? And the other way we get square root answers is from the quadratic formula. And when you think about the quadratic formula, right in front of the square root is a plus or minus. The opposite of b, plus or minus. So it makes sense to have both irrational solutions be zeros. Okay? We're going to look at an example. Write this down in your notes. Write the polynomial that has the zeros 0 and square root 7. How many zeros are listed? I gave you how many there? 2. But because we know the irrational conjugates theorem, if a square root of 7 is a solution, then its conjugate negative square root of 7 must also be a solution. So how many zeros are there really?
3.
There's really 3. Okay, so we want to write that down. If the square root of 7 is a solution, then negative square root of 7 is also a solution. And that's because the irrational conjugate theorem says so. And we kind of agreed that there should be a plus or minus. So when we write out our factors, we'll still have 3 factors. What's my first factor going to look like? X minus 0. My next factor is going to be x minus square root of 7. And the other one's going to be x plus the square root of 7, because minus and negative would be plus. Are you okay with my factors there? Let's talk about it if we're not. Faith. Oh, so what would you rather write? You have no idea? Well, you can, yes, but we're always, when we write factors, we're always like subtracting the number. So like when the number is 2, we're writing x minus 2. And when the solution was negative 2, we're writing x minus negative 2, which is really x plus 2. So you can still subtract 0, can't you? I guess I'm not calling it a negative 0, I'm subtracting 0 in this case. What is x minus 0? X. So if you didn't want to write x minus 0, could we just change it to x? Yeah, let's do that. Let's just change it to x then, if we dislike it. It's really the same thing. X minus 0 is really just x. And then you don't have to worry about it. I do that all the time with my 0. Any other questions? Are we okay with why I have minus square root 7 and plus square root 7? They should be opposites because one is positive and one is negative. Okay. Okay, so let's multiply the conjugates first because this is going to work out nicely for us. Okay. We're going to multiply these two. What's x times x? X squared. What's x times the square root of 7? X square root 7. Yuck. What's negative square root 7 times x? Negative x square root 7. And what's the negative square root of 7 times a positive square root of 7? A negative times a positive is a negative square root 7 times itself is 7. So minus 7. So for those of us who like to see all of FOIL, there's all of FOIL. What do you notice about your outside and inside terms? They cancel. Perfect. They were yucky. They had irrational numbers, right? But they cancel each other out, and they always will. So do I ever write them? No. It just makes my work look messy. It's going to be x squared minus 7. Jackson, you have a question?
No, you just answered it.
Okay. I got so excited. This makes sense. If x squared minus 7 is a factor, think about like if it was yesterday and that was your factor and you're supposed to set your factor equal to 0. How do you solve for x? First you add 7, so you get x squared equals 7, and then you take the square root of both sides, but when you take the square root of both sides, you add a plus or minus. And there's your two answers, right? So x squared minus 7 must have been the answer. Now we're still multiplying it by x, right? So our final answer will be x cubed minus 7x. Using what you know about conjugates and how they multiply and how your outside and inside terms will always cancel, can you try to write the polynomial that has zeros 2 and negative square root of 3? I only give you 2 zeros, but you know there are really 3 zeros here because of the irrational conjugate theorem. Could you please write out your factors and try to multiply them? anytime I use the conjugates theorem, I'll always multiply my conjugates together first. That's the easiest option for multiplication. So multiply x plus the square root of 3 times x minus the square root of 3. If you want to write down all the terms, write down all the terms. But you should find that your irrational terms will cancel. So on this one, we don't have a 0, so you shouldn't have this x. You should have x minus 2. You should have x plus the square root of 3, but then we need its conjugate. Because if this is a 0, part of your square root is also 0. Be very careful. We multiply this one into negative times a positive in that. We get negative square root of 3 times a positive square root of 3. Even with the minus.
Square root of 3 times
When you take a square root and inside, you get this. Oh, because it's a negative and the positive.
and then after that, I think.
What is minus plus? What is minus? It's negative square root of 3. So negative. If they were both positive or both negative, then it would be plus. Okay. If I FOIL out my conjugates here, I'll get x squared minus x square root 3 plus x square root 3, and then the positive square root of 3 times the negative square root of 3 will be negative 3. And my outside inside terms will cancel just like I wanted them to. So I'll have x squared minus 3 right there. And that makes sense, right? Think about if you were going to set that equal to 0 and solve. You'd add 3, you'd square root both sides and add the plus or minus, so you'd have plus or minus square root of 3. Okay, it works out. Don't forget to multiply by your factor in front. That's your x minus 2. So your final answer in this example is x cubed minus 2x squared minus 3x plus 6. Is there anything in that multiplication we should talk about? Hopefully you start to catch on to a pattern, like if the square root of 5 is a solution, then negative square root of 5 is a solution, and then the factor was x squared minus 5. If 17, the square root of 17 was the solution, then negative square root of 17 is also a solution, and x squared minus 17 is the factor. Okay, so it follows a pattern, and the more you practice it, it starts to really come together, and then you can not have to FOIL it every time. Okay. One more thing to talk about is the complex conjugates theorem. It's almost the same thing, but it has imaginary numbers because it's complex. So this says if a plus bi is a 0, then its partner a minus bi is also a 0. Okay, and the same thing is true with the complex conjugates as the irrational conjugates theorem. We're going to focus on the imaginary part, the plus bi and the minus bi. Okay, so we're going to have imaginary solutions. We'll do an example. We're going to write a polynomial that has zeros, -1 and 4i. I only give you 2 zeros, but since one of them is complex 4i, you know it has a partner, right? What's the partner to 4i? -4i. Okay, so there are really 3 zeros here. And then I write them as factors. If negative 1 was the solution, then the factor is x minus negative 1, which is really x plus 1. For 4i, it's x minus 4i. And for negative 4i, it's x minus negative 4i, so x plus 4i. You can never have just one imaginary factor. There is always two of them. We'll multiply the conjugates first. What's x times x? X squared. And would you agree the outside and the insides are going to cancel? 4ix, negative 4ix, totally gone. So let's just multiply the last two. What's negative 4i times positive 4i? A negative times a positive is a negative. 4 times 4 is, and I times I is. And then pull the information out from chapter 3. What do you remember about I squared? It's equal to negative 1. So I squared is equal to negative 1, which means this is really x squared plus 16. And we multiply by x plus 1. That x squared plus 16 factor makes just as much sense as our x squared minus 7 factor, right? If you were going to solve that factor at the end, you'd subtract 16. You'd end up taking the square root of a negative, which would be imaginary, and you'd include a plus or minus. So you'd still get plus or minus 4i. And so this makes sense when you get this answer. Distribute your terms, and your final polynomial should be x cubed plus x squared plus 16x plus 16. Does anybody have any questions there? Okay, so it's a lot of multiplication. Be careful with the irrationals and complex. Make sure you include their partner. When you write your polynomials tonight, they should have all rational coefficients. So if any of the coefficients in your polynomial are imaginary or irrational with square roots, you probably didn't include the missing 0. Okay, so just kind of be aware of that. Your homework, I have to write on the board.